All right. Everybody, can you hear me? Hear ye, hear ye. If you guys can move to the front, we're about to get started here. All right, much appreciated. Good deal. All right. Welcome, everybody, to the first in-person computer vision meetup in Austin, Texas. We're actually part of a global network of computer vision meetups that stretches all the way from Boston all the way to Bangalore. So glad that you could join us here today. I am your host, Daryl Malone, and I'm also the developer advocate at Eagle Eye Networks. So, the computer vision world has gotten a little bit of turbocharging recently. Part of that is due to advances in large language models, as well as other innovative uses of transformers. So just to give you a couple of examples, you've got generative AI that you can now use to generate synthetic training data, which is huge impact, makes it a lot easier to start to build up and train models, makes it more accessible. You've got transformers themselves, vision transformers, that are now starting to compete with and then sometimes are actually beating the previous gold standard of convolutional neural nets. You've also got multimodal AI systems, so a combination of LLMs and computer vision that are now starting to help bridge the gap between machine predictions and the human interpretation and ability to do something with that information. So a lot of big changes. and that is having an impact and showing in the numbers. In 2020, the computer vision industry was making $14 billion in revenue globally. 2021, that jumped up to $28 billion. And after the COVID, jump and then trough, we started to see pretty steady, about 20% growth that went from 2022 to 2023, and another 18% that's predicted to happen this year, bringing us to 26 billion. Yeah, go ahead.
How are you defining computer vision market?
So this is actually made up of a number of different revenue sources. So this is between facial recognition technologies. This includes, the image recognition technologies, and then there's kind of another broad scope. So this is from market.scoop US. But yeah, so obviously we're seeing pretty serious growth continuing to happen. So the question is, cui bono? Who's actually benefiting from all of this new revenue that's being generated? Other than NVIDIA. So you wouldn't be surprised to know that two of the biggest cities that are really benefiting from this, especially in the United States, are going to be San Francisco and Boston. So if you look at San Francisco, case is obvious. You've got some of the biggest technology companies in the world, all concentrated there, as well as two extremely prevalent universities in the world of computer vision, UC Berkeley and Stanford. Gives them a huge advantage in the space. You look at Boston, you see a similar story. MIT is obviously one of the premier technology institutions in the world. And then at the same time, you've got a lot of very innovative and niche deep tech startups that also build up the community there. But I wouldn't necessarily count Austin out just yet. Number one, we've got an extremely innovative and really powerful business community right here. When I first moved here to Austin, we had a startup density of 128 companies, startup companies, to every 100,000 residents. That's companies of all types. If you look at just technology companies, at that time we had like in the hundreds, several hundred technology companies here in town. This year, we're pushing 3,000, and we're getting more and more capital coming in every day. And on top of that, don't forget that UT is actually a pretty powerful institution in its own right? Maybe it doesn't have the same sort of deep tech gravitas as an MIT. Yes, I was born in Massachusetts. I don't know what that has to do with anything, but let's move on. But even so, UT Austin has a technology or a computer science department that is frequently in the top 5 in the country. So definitely no slouch. On top of that, we've got facilities like the TACC, so that's Texas Advanced Computing Center, which hosts systems like Lone Star 6, which is a great platform for people who are doing research in computer science, machine learning, AI, those sorts of things. That's just one of many systems that they host here at UT. And on top of that, most people, myself included, would much rather live here in Austin than in Boston or San Francisco. Let's be real. So the big part, so there's really no reason that we can't have a world-class, top-of-the-line computer vision community right here in Austin. And the key to making that happen, one of many, but a big one, is networking. It's making sure that all of you here in this room can meet your next co-founder, can meet your next partner, can meet your next hire, and your next customer. Those collisions, those connections are the lifeblood of any innovation economy. So my offer and my deal with you today is that I'm going to do my utmost to make sure that this space contains some of the most innovative and interesting people in the computer vision space. You guys keep coming here and enjoying the pizza. Sound good? All right, good deal. Now, before we begin, I'm going to have our sponsors come up and say a few words. Hunter, do you want to start us off? Everybody give him a hand.
Thank you, Daryl. Daryl, you're a very, very well-spoken man. I appreciate you. So, hello, everybody. Thank you all for coming out. I know it's a little bit of effort after work, but we appreciate you. And yeah, it should be a fun little event. Anyways, my name is Hunter. I have been with Voxel 51 for about a year now, but I've been in the computer vision space for about 4 years. Really love helping teams solve hard problems with visual data. And just real quickly before I talk about 51, has anybody heard of Voxel 51 or used our open source tool before? Great, my colleagues, I love that, that's good. But just from a super high level, Dan's gonna go super deep on this, but we are a refinery for your visual AI. We give you one place to refine your data and your models together. And we're really built for machine learning teams that want full control of their machine learning pipeline. The reason why people love us is because we're fully open source. So post this event, we hope that you guys go home, especially those software engineers, computer vision engineers, pip install 51 on your local machine and join our community. Thank you very much.
Thank you, Hunter. And next from Eagle Eye, we have Jason DeMang. Let's give him a hand.
Thanks a lot, guys. I'm not going to talk much about Eagle Eye because you're about to hear from our founder, Dean Drako, who's going to give you a great background. But as you're listening to what he's talking about, I want you to keep something in mind. Everything he's talking about is all the heavy lifting over the past 10, 12 years that we built to build the infrastructure, the scale of our cloud video management system. And we offer, and what I do for Eagle Eye is an API program. It's a developer's program. We have an open API. You could leverage all that infrastructure, all those connections, all those connected cameras to build some really, really interesting applications. And Dean's going to spark some ideas on that. And so if you guys see these QR codes around, you can scan that and go create a free developer account on our developer hub and start playing around with our APIs and start seeing just the power that we can offer you. So thanks for showing up.
All right. Thanks, Jason. Okay, so the moment you've all been waiting for. Let's go ahead and get started. First speaker is going to be Dean Drako. 25 years of experience building profitable companies, chairman of Brevo, founder and CEO of Eagle Eye, former founder and CEO of Barracuda Networks. Dean Drako is obviously incredibly successful and good guy. I'm not just saying that because I work for him and he signed my checks. So why don't you go ahead and join us on the stage?
All right. Thank you, everybody. Appreciate it. Thank you for that lovely introduction. Also like to say thanks to Capital Factory and Josh Baer and for driving entrepreneurship in Austin. He was one of the folks who welcomed me to Austin roughly 15 years ago when I first kind of came to Austin and moved the fledgling Eagle Eye Networks, which was like about 4 or 5 employees, to Austin, and basically kick things off here. So, don't know exactly what you guys would like to hear about. I have some slides. We can skip them. We can present them. You know, we can talk about them. So think about any questions you might have. I'm going to go through, you know, some stuff that I thought might be interesting to a group of people that are in, you know, kind of computer vision. But since this is our first computer vision meeting here in Austin, you know, we're pretty flexible on kind of what we talk about. So, does this thing work? Not really, huh? Yeah, I know, that seems to work. All right, I'm gonna leave this with you. So I've kind of I studied electrical engineering at University of Michigan, and then did a graduate degree at UC Berkeley in computer and electrical engineering. My background was all in semiconductor design, semiconductor physics, kind of heavy lifting stuff in college. But I had done a lot of programming, and in high school, I had actually written on an Apple II, not an Apple II Plus, an Apple II, a bulletin board system. Does anybody even know what a bulletin board system is? Yeah, predecessor of the internet. I sold that during high school as a software package to corporate America for $100 a copy, and that was how I paid for college. Yeah, and so graduating from college, I went to work at Apple, designed one of the Macintoshes that rolled out, actually the first RISC-based Macintosh, if anybody knows what that is. And then I left and did a video game company where I was employee 10, which first tech company ever to go public without revenue in 1993. If you can imagine that. And then I started my own companies. And I started a company that was in the semiconductor design space, doing EDA software, and I sold that to Cadence. And then I started Barracuda Networks in the spam space, in the cybersecurity space. And that was a fun ride. We eventually took that public. And I started Eagle Eye Networks, and I bought this company, Brevo. And I started another company, Swift Sensors. And then a few weeks back, I bought another company called Cobalt AI, which is a robot company. So anyway, so a lot of fun stuff. So we're going to talk a little bit more about, what are we going to talk about? Let's see. Yeah, all right. So in 2010, I was running Barracuda Networks. And Barracuda Networks, I had expanded pretty broadly. We had offices in 4 or 5 countries in Europe, an office in Shanghai, office in Japan, office in Latin America. And I was pretty obsessed with customer service, okay? And the way I really encourage customer service at Barracuda's headquarters, we had to be open. We were on the West Coast. We were in Silicon Valley. We needed to answer the phone from 8 a.m. East Coast time, okay, until 6 p.m. West Coast time for customers, okay, for sales customers. Support operated 24/7, but for sales, we still needed to provide great service. And there was a little bit of a problem that would go on because not a lot of people want to come to work at 5 in the morning, okay? And the East Coast kind of wakes up at 8, but the East Coast really kind of gets started about 9, okay? And so there's not a lot of phone calls coming in at 5 a.m. in the morning for the sales department. So the salespeople would kind of get a little lazy and come in at 5:15 and then 5:30, and nobody would notice. And then pretty soon they're showing up at 6. So I would get up in the morning and I'd call them at 5 a.m. And if they didn't answer, then they get fired. It was pretty simple, right? Do that once, and the understanding of the rules of the road get clear to everybody, and the person that's supposed to be there at 5 shows up at 5 and plays video games or whatever they're going to do, right? But at least they're there. And so I wanted to have I was very concerned about a similar level of service internationally, because if you want to go international, okay, and you want to sell internationally, you have to go local. You can't sell a product, okay, in a different foreign market that speaks a different language from the U.S., okay, without an office, without a person who's a local person, etc. You have to go local if you want to be successful. That means local support, that means local engineering, that means local documentation, that means a local office, that means local salespeople. Okay, so I was doing that. And I was very concerned that the people weren't really going to be there to answer the phones from 8 o'clock to 5 o'clock. And so I said, hey, I'll just put a camera, and I'll just make sure they show up, right? I just want them to show up. If they're in the office, they'll answer the phone. Not like they're going to be in the office and not answer the phone. And so I kind of said, hey, we'll go get some cameras. And so I went on the internet and I said, okay, I'll just, the cloud's taken off. We've been using Salesforce.com here at Barracuda Networks for like 10 years. Okay, I was like Benioff's like 3rd customer or something. Okay, and I get on the internet and I cannot find a single cloud-based camera system, not one. I literally spent weeks surfing the internet trying to find a camera system that was connected to the cloud. Didn't exist. Okay, and so I'm like, wow, what an opportunity. We got a $50 billion industry, security cameras everywhere. People are using them for all kinds of stuff. And they have no idea that the cloud even exists as an industry. So I said, oh my God, I gotta go do this. So I created Eagle Eye Networks to basically bring the cloud and AI to the video surveillance industry because they weren't really thinking about it. Now, since then, everybody and the brother has gotten on my bandwagon, which is all fine. Nothing like imitation is the sincerest form of flattery, as they say. So that's what Eagle Eye Networks has been about. And when we started it, we kind of made a couple of strategic decisions. One was that we were going to store a lot of video in the cloud. And if you're going to store a lot of video in the cloud, you can't do that on Amazon AWS because it's just too expensive. You can't do it on GCP. It's just too expensive. So we kind of jumped full hog into deploying data centers and the whole kind of thing. All right, what's the next slide? Open. All right, so one of the other things that was very odd about the video surveillance industry at the time, right? The video surveillance industry consists of security cameras, okay, PCs that have been kind of souped up with a lot of storage, and then some software that you install on them. That's kind of the high-end kind of thing. You get a rack of computers and you store a lot of video on it. And then in the mid-range, you buy a box, a DVR. And at the time, they all had the big knob on the front of them, just like the VCR, okay? Even though they had a hard disk in them, they still kept the big knob because they were supposed to have a big knob to do whatever the big knob does, okay? And so, but one of the funny things about it was the industry was all like very closed. It was all, if you wanted to get, it was all Windows-based, but if you wanted to interface software to their Windows software and use their DLLs or whatever, you had to like go through an NDA process, you had to sign contracts, okay? And then they would actually give you the documentation on, the APIs that you could integrate. And I was just like, this is crazy. Like, this is like so 1990s. Like, the world now is kind of open platform, open APIs, REST APIs, et cetera. So we went contrary to the grain and basically said, hey, we're going to have fully open APIs, okay, that are documented using modern structure, using a REST API for a cloud service. And so we ended up with a very open platform. And part of that is what's might be interesting to some of you folks is how to use that platform for doing either video surveillance or doing image or computer vision or AI. Okay, what's the next slide? I don't even remember. Okay, aha. So AI kind of was talked about in 2013, 2014, 2015, 2016, 2017, 2018, 2019, 2020. Okay, and then finally around 2021, 2022, 2019, I don't exactly remember when, but it started to actually become kind of real. Like, and in my space, or in our space, it was all about AI kind of for vision or video analytics or identifying things in images. And so what was interesting to me, and I give this analogy all the time, is AI is having, huge impact on all kinds of industries, okay? But some industries are going to have more impact from AI than others. So if you think about it, the guys who make these chairs, okay, AI is probably not going to have a whole lot of impact on their business. It'll have some, optimize their supply chain, or maybe they'll put an AI on their website to answer questions about their chairs. Okay, the grocery business, AI is, you're still going to go to the grocery store and you're still going to get the same cart and you're still going to push it around and put your food in it, okay? Maybe the shelves are stocked a little better. Maybe they magically give you some coupons on your phone. Who knows? AI will have impact, but the impact on it will be very small. On the other hand, the automobile industry, right, AI is going to really turn them sideways, Okay, I'm no longer going to buy a car from the automobile industry. I'm going to buy a self-driving transportation thing, right? It's not really even a car anymore. It's going to drive itself. Okay, that's crazy, right? You know, like the car used to be 90% steel, 2% software, and 8% electronics. Okay, from a cost point of view and a mass point of view. Okay, but that's going to just flip, right? The hardware is going to become 25% of the cost, 20% of the cost. The software and the electronics and all the stuff to make it self-driving is going to end up being 80% of the value of the car. Okay, that is a huge change. That, I mean, like the industry is just being turned upside down, and you can kind of see it going on. The video surveillance industry, the industry I'm in, video security, video surveillance, video systems, is going to have is undergoing a similar revolution as the auto industry, right? Everything's being turned on its head. The video surveillance that we used to do, or that the industry used to do, is you would sell cameras, people would install the cameras would record video, and pretty much nobody would look at it, okay? Like, we would always say, you know, some people watch some of the cameras a little bit of the time, okay? There's about 1 billion cameras in the world today, okay? In order to watch them all, you would need about 1 billion people, okay? So there's clearly not 1 billion people watching cameras 24 hours a day. Actually, I guess you need 3 billion people because they can only watch like roughly 8 hours a day, maybe. And so, you know, we have security guards. There's one out here, and, you know, it's got like 10 or 20 cameras up on a bunch of screens. You can go look. But they don't really pay that much attention to them. Okay, most of the stuff comes and goes on those cameras, and, you know, it's been proven that a security person can watch cameras for about 15 minutes, and then they tune it all out. Now, you might catch something, okay, but that's unusual, okay? But with AI, we can actually watch all the cameras all the time instead of few of the cameras little at the time. And we can watch the cameras for all kinds of interesting things. And so what happens is we're no longer selling a video surveillance solution to the customer. We are actually selling a AI safety system, an AI security system. It's an AI kind of monitoring and watching for bad things system. So it's a completely different product with a completely different value equation. Just like in the automobile industry, it's a completely different product. And so my point is some industries, okay, video surveillance, automobiles, probably some other ones, okay, probably some customer support ones, I don't know, there's probably a whole bunch of other ones, are going to be turned really significantly into a different business, very disrupted by AI. And when you're thinking about like what you want to do, when there's disruption, there's money to be made. Okay? That's where the startup companies come from, when there's disruption. Okay? If you think about, anyway, there's just opportunity when disruption occurs. And so that was part of the reason I got into this, is because I knew the cloud and AI were going to disrupt the video surveillance business. And obviously, people talk a lot about AI at the edge. Okay? Why do they talk about AI at the edge? What's that? Yeah, well, why, you know, why would you do anything at the edge? Yeah, response time, maybe. Okay, but in reality, you don't want to do anything at the edge. Okay? It's a pain in the arse. Okay? You got thousands, you know, like right now at Eagle Eye, we have like 200,000 edge compute devices. Do you know how hard it is to manage them, keep them up to date, firmware updates, reliability? Like, it's a complete mess. It's a nightmare, okay? What's that? I can get into that. But anyway, so people talk about a compute at the edge. Do you know who the guys are that talk about the compute at the edge? It's the semiconductor companies that want to sell chips, okay? That's how they talk about compute at the edge. Okay, doing AI at the edge is like hypercompute. Like, you're going to push your model and you're going to push your AI at the edge. You're going to buy some box, okay? And like 6 months later, the box is going to be too slow to do the AI you want, and the models are going to have gotten too big and too complicated, and you're going to need to change those boxes. Or like 3 years later, the box is going to be useless, and you're going to have to figure out how to go through an upgrade cycle. Anyway, so AI in the cloud makes a lot more sense, okay? ChatGPT doesn't run on the edge, okay, right? There's a reason, and then they can upgrade it. Boom, upgrade. Hey, now it's ChatGPT 4 point whatever. Here's the beta for chat. Like, you're doing AI at the edge. You can't do that stuff. It's really hard. So anyway, I'm a big believer in kind of the combination of the cloud along with AI having a significant impact on the video surveillance kind of space. Why do we have boxes at the edge? Okay, so what we started and what we continue to do is the first thing that we had to do as a company at Eagle Eye is we had to become plumbers, okay? And plumbing is a horrifically bad profession. Don't let anyone go into plumbing in your family. It's an ugly job. Like water, it leaks. You gotta cut. Anyway, it's a very rough job. It's like the hardest construction job there is. Electricians have it easy. The framers have it easy. The roofing guys have it easy. The plumbers are the ones who have it really hard. Anyway, we got into the plumbing business. And now the plumbing business is, how do you get all the video, okay, from 150 different camera manufacturers who each have 2,000 models of camera, every one of which is different and behaves differently and has weird bugs and crashes, okay? Different parameters, different features. How do you get all of those cameras to transmit video up to the cloud securely, safely, reliably, okay, so that you can have one API in the cloud that allows you to do development of AI and user interfaces and all this stuff on this huge variety of video sources. So we support something like 20,000 different makes and models of cameras that we make all look the same, okay? None of these cameras had any security, any encryption, any SSL, okay, any semblance of that. So you couldn't talk to them directly from the cloud. So we had to have a little box at the edge, kind of like a little modem box, that you get from your carrier, to basically do all of that and then get the video up to the cloud. So then we can start to do AI and analytics, give you a user interface, give you a mobile app, all that kind of fun stuff. So that's why we have the little box. Anyway, where was I going? What's next? Oh, no, go back. Oh yeah, I think we talked about that. Okay, so now that we got all the plumbing done, we got the plumbing done about 4 or 5 years ago, to get it all reliable. Now there's an API in the cloud that has access to millions of cameras, okay? And we have a whole bunch of companies building on top of our APIs, different AI applications, different features, different capabilities, okay? And as a developer, you can kind of ignore the problem of all the plumbing, because we took care of all the plumbing, okay? And add onto the platform and go and do kind of interesting stuff. And what I have next is kind of a long kind of list of interesting things, ideas. We have some companies chasing some of these. We have some of them we're chasing. But there's like an endless list of the stuff that's going to go down for computer vision on top of the Eagle Eye platform and maybe other platforms. So license plate recognition has become a monstrous thing. People are using it for safety and security. They want to use it at schools to make sure the right parents are dropping off the right kids. They're using it in parking lots. So we supply like Smart Park and I don't remember, a couple of the big parking guys with technology to do all the parking stuff. So you can drive in and drive out and they charge your credit card, okay? All the cars are driving around, the police cars are driving around and they're scanning all the license plates they see with cameras and running checks to find the stolen cars and the bad actors. And then on top of that, drive-throughs and fast food people and the banks are also taking the license plates and comparing them to basically keep their people safe. So i.e. if someone shows up in the parking lot or is going through the drive-through and is a bad actor, they want to make sure their people are safe and don't get threatened or in trouble. So anyway, all kinds of kind of LPR applications. LPR has been around a long time, okay, and it was roughly 92, 93% accurate using OCR. But then when the AI kicked in, okay, into it a couple years ago, we were able to get the accuracy rates up, you know, to more like 97, 98%. And it's a very hard problem. And you know, this slide doesn't really quite do it justice, but if you start to, there's like new license plates in every state every year, okay, that screw things up. And then you have people without plates, and you have people with, you know, those paper plates and fake plates, and you know, it gets pretty hard. And then when you go internationally, it gets completely crazy. So it's not an easy problem. Like my favorite is, anyway, there's just crazy examples we've seen of the advertising on the back of this truck was 5 painted license plates. Okay, and you know, they were a little bigger, okay, but you still had to pick.
U-Haul does that on the back of the trucks. They put the license plates.
Yeah, yeah. So anyway, there's a bunch of things, and then you know, people have stickers and bumper stickers and all kinds of stuff on the back of their cars, and you know, it gets a little. It's you know, it's a challenging problem, and then you know, you don't always get the best view, and sometimes you get the front plate and there's no back plate no front plate. Sometimes front plates in the windshield. You know, anyway, all kinds of stuff. So, but it's a good AI-ish problem, right? Because if you get the right training set, get the right models, you can have a lot of fun and you can get a lot more accurate than you can with a hand-coded algorithm or OCR kinds of technology, right? The old algorithm was, you know, try and find the license plate, okay, using kind of hand-coded kind of stuff. And then, okay, great, we found the license plate. Now let's run some OCR on it, okay? Well, now you're just training a model on the whole back of the vehicle, right, to identify and pull it out. So a lot of fun and a lot more accurate. We're doing a new one, which we had a lot of customers come in, and they want to get DOT numbers off the sides of trucks so they can route the trucks to the right docks and place them and let them in and not have to do as much security on them and a whole thing. And then there's a whole bunch of stuff going on PPE, safety equipment, right? Construction guys, the insurance folks, very concerned about everybody wearing the right equipment and being safe. They don't want to get fined. They don't want people to get hurt. They want to enforce politely and strongly. And so they want basically, you know, to create scores and chastise people who are misbehaving and whole systems around that. And then there's a whole system of extracting faces and AI to basically do blurring and disguise, basically giving people privacy, but still having the video to make sure things are going the way they want. And then there's a whole set of applications in manufacturing, okay, manufacturing line efficiency that go way beyond kind of security. And then the application that is starting to take off right now, still the tech isn't quite there, okay? It's starting to be there, okay? And that is weapons detection, okay, which is very popular for corporate America, schools, and a whole bunch of other places. We're very interested in how do we do weapons and threat detection, okay? And there's even some companies working on fight detection, okay, violence detection, anomaly detection, et cetera. Yeah, all of this is headed to kind of 3D kinds of views. There's a whole bunch of stuff with AI to follow people through cameras, right? You know, they go from this one to this one, this one. I want to follow where they went and all that kind of stuff, okay? And then obviously face matching and face searching, okay, which are different than kind of facial recognition. Facial recognition, there's a whole bunch of controversy around facial recognition, around without consent. I think that we're going to end up in a place in the United States and the Western world where in order to do real facial recognition, you need to get consent of the people that are being facially recognized. However, I think facial matching, i.e. I saw this guy, where else did this guy go in my building, will become something that is generally acceptable. I don't know who he is, but I got this picture when he came in the door. Show me where else he went, because I think he was doing something he shouldn't have been doing. I don't know who he is, okay? But anyway, but for employees, I think you're going to get to this place where security cameras are placed in a building, maybe a big corporate building like Google, and when you come in and register and you're an employee, right, they take a picture, they make a name badge, okay, and they're going to have cameras throughout the building, and if there's anybody who's not an employee who shows up in the cameras, they're going to go, okay, well, who is this person and why are they here? Or, especially in a secure area, like, Apple probably has a few of those, right? Non-employees would get flagged and security would maybe go and say, hey, what are you doing here, kind of thing. So I think we're headed to a zone where all of that kind of stuff is a reality. Shoplifting detection is a big thing. A lot of people working on that. No one's kind of cracked the nut on that yet. Oops, slip and fall detection, pretty common. Nice thing about it is you can run it in any office building. People slipping and falling is a problem, right? People want to know about it. So a lot of AI kind of on that kind of stuff. Fire detection on cameras. We got all these great fire sprinkler systems and smoke alarms and all that kind of stuff, but you got all these cameras. They can detect fire and smoke actually probably better than most of those systems. So anomaly detection, that's just detecting stuff that's out of the ordinary, which is very, very, very common because that's what a security guard wants. They want to know the anomalies, anything that's odd. And then tying this all into access control systems, which is kind of one of the other businesses I'm in, is kind of a big thing. And then, line queuing, are the lines too long? Do I need more people? We have a lot of customers at Eagle Eye that use the cameras to allocate their people. It's like their haircut kind of thing. They have a bunch of places where they do haircuts. One's got a lot of people, one doesn't. They'll actually send somebody from one to another that's 5 miles away to basically cover the workload. Okay, a lot of restaurant management stuff. Are the tables clean? Are the tables dirty? Are people happy? Are they smiling? Is the food good? Is the busboy doing his job? All kinds of things that are going on in the restaurant space with AI. We don't need to watch this. You can skip this. I think that's about kind of most it. So there's a lot of crazy opportunity here that is going to apply to like all kinds of industries. Everything from the public sector and the safe city kind of stuff to restaurant management to production line to basically anyway, any and all industries, we're going to be able to apply the video. And so the reason I'm excited about this space is video surveillance, which has traditionally been, safety and security and forensics, let's look at what happened, is now becoming proactive, different product. And that product is going to go well beyond safety and security. And with the APIs, we're kind of creating a platform so that anybody and everybody can kind of go and develop their, specific application. I'm going to put cameras on the doggy daycare and, make sure that all the dogs are happy or in the right place or, whatever the doggy daycare kind of folks need. Or, I'm going to put cameras on the parking lot at, the airport, okay, and make sure that no one's running around, trying to break into the cars in the parking lot where people have parked or whatever it is. Or, there's the one parking lot, the blue parking lot at Austin, has all those kind of sensors to tell you where the empty parking places are. and they actually take your license plate so that you can look it up where you forgot you put your car. Okay, so yet another application. I think that one's a little crazy because it takes a few too many cameras, but anyway, they installed it, they paid for it, and it seems to work. So hey, more tech. It's good for everyone in this room. Okay, so anyway, I'm a big fan of open kind of platforms, Any questions? What would you like to hear about? Okay, so we sell a cloud video management system. So if you buy the full system from us, you can buy cameras. Okay, you hang the cameras up. Cameras in this room are actually all Eagle Eye cameras. The cameras then talk to a little box that we call a bridge, which you buy from us. Okay, cameras record the video, send it to the bridge. The bridge sends it to the cloud. Cloud stores it for 30 days, 60 days, 10 years, however long you want. And then you go to your little iPhone or your web browser, and you can watch the video, look at the video, historic video, and then you can set up AI rules of, like, if there's a fire on any camera, okay, dial 911. If there's anyone in the building after midnight to 5 a.m., send me an email with a picture of them, because nobody should be in the building during those hours, and I want to know about it if somebody is. You know, on and on and on. Correct. We provide a canned set of use cases, but then we have the open APIs so that a customer can go to anybody they want and add capabilities, add AI, add this specific AI, add that specific AI to their particular installation. Make sense? Got it? All right. What do we got back there? Correct. Yeah. So, you know, all of this is, we operate 11 data centers across the globe, two in the United States, 1 in Canada, 2 in Japan, 3 or 4 in Europe, etc. Because people really don't want their video data going out country, is what it really boils down to. And the cost of the storage, I mean, we store video. So I always explain it. Everybody knows what a gigabyte is, right? Okay. Everybody knows what a terabyte is. Okay. Everybody knows what a petabyte is. Okay. So we count our storage in exabytes. Okay. Which most people don't even know what that is. Yeah. Okay. So it's just massive amounts of storage. We store everything in the Eagle Eye Cloud in triplicate, okay, which is also a little unusual, but it has to do with our architecture to make sure it's, you know, 99.9 whatever percent reliable, and that we don't lose video ever, kind of thing. And then on top of that whole big infrastructure are the APIs. And if you use the APIs, you're going to be adding more cameras, and then you have to pay us for the cameras. We charge per camera, basically, you know, with this little matrix of pricing. Okay. Go ahead.
I saw a table out front with the cardboard boxes full of Eagle Eye logos. What are those about?
Everybody gets a free, what are those called? Cup? Tumbler. We have a free tumbler for everybody who asks a question.
All right, so it sounds like this was born out of your wanting to make sure people are getting their job done at 5 in the morning. So I'm very curious, like a little bit, like the idea, the inception. And then it sounds like with your product, you have a preset defined set of use cases that you used to sell, and then you have the open developer account so people can configure it. How did you go about determining the preset amount of cases for sales? Were they all like personal scenarios and problems that you encountered?
No, I mean, so they've been driven by customers. Okay, you know, so we have a lot of customers on the platform today, and you know, those customers come to us and, you know, say, hey, you know, we want this, or we want to use your platform, but we want this, and we'll kind of go and say, okay, can we find a third party who's doing it, or should we do it? You know, is it a large enough use case that makes sense for us to, you know, do we have the resources, you know, that kind of thing.
Did you have one to start selling off to kind of validate your idea?
Not really, no. You know, we launched the product. Well, I can tell you the story of the history of the product. Okay, so when I was at Barracuda, I kind of did a pre-product, okay, kind of incarnation V1, and we made a few mistakes. Okay, we actually started designing. There were no cameras. The market, the world was so closed at the time when we started V1 at Barracuda Networks that there was no ability to talk to any camera that any manufacturer made without proprietary secret sauce, okay? And so we had to make our own cameras. And that's doable, but it's hard because people have a lot of preferences for the cameras. They want blue ones, they want black ones, they want white ones, they want small ones, they want outdoor ones, they want indoor ones. There's just, you know, in order to have a full line of security cameras, it's like 100 different variations, okay? And to just kind of go do that out of the gate is hard for a startup or a smaller project. So anyway, we struggled and made some mistakes. And then in 2012, I basically said, okay, I know how to do this now the right way. And so I started in 2013 Eagle Eye Networks and said, you know, it needs to be a separate company and a whole bunch of things. And instead of making our own cameras, at that point, there had started to develop some openness on the talking to the cameras. And so we were able to leverage that and do the bridge and talk to the cameras. But 2014, 15, 16, 17, 18, and 19, well, 2018, like the first 5 years of sales, I was literally beating my head against a concrete wall trying to convince an industry that the cloud was a better answer. And the stories I got from the potential customers were just outlandish. It was like, oh, the cloud's not secure. It's more secure for me to keep my video under my desk, okay? You know, and everything under the sun, you know, there's not enough bandwidth, you know, story after story after story. And then in 2018, 2019, the security guys started to get more influenced by the IT guys because the cybersecurity issues started to become more significant. And so the IT teams were directed to, hey, you know, we got these PCs that these security guys got, and like, you guys, IT guys, you better go check and make sure they're secure, okay? Because they haven't been upgraded in 5 years. Okay, and there's no antivirus software on them, and they're connected to the internet, and like, you know, you IT guys better get this under control. And so then the IT guys started to engage, and they started to go, well, what do you mean it's not in the cloud? Right? And so we started to kind of actually get some traction. So the first 5 years were pretty brutal. We got customers, just not a lot. And then kind of the floodgates started to open.
All right. I think we're going to let Dan go ahead.
Dan, go ahead. Who's Dan?
That's going to be our next speaker.
Okay. Anyway, let's do 2 more questions. These people have been waiting nicely. What do you got?
I just wanted to ask, in terms of competitors, I think like Ubiquity, folks that offer lots of cameras and web UIs, what's that scene look like? And then on the flip side of it, like I was telling Daryl, I like finding out when raccoons are in the chicken coop. And I can get on Amazon and get a ton of cheap-ass cameras. It'll tell me when something's there, but where's that data go? And how does that play with the value?
Yeah, so Ubiquity and kind of the low-end consumer kind of stuff where you buy cameras for $20 or Wix or Wikis and whatever. We don't generally play in that market. We play in kind of the commercial kind of spaces market. So we don't sell to consumers. We're focused on, you know, big retailers, people with a global footprint, you know, all commercial. You know, sometimes it's small. Might be a big guy with a couple gas stations. But, you know, they're not interested. The consumer stuff doesn't really cut it because you don't get a reliable enough kind of thing. Most of our customers, you know, really need the video 24/7. They can't afford to lose some video kind of thing. Over there? No?
A couple of very quick ones.
Yep.
You mentioned this capability didn't exist. I'm assuming that the feds have
Well, there's different level of feds, right? Yeah. So the feds are still pretty old school. They haven't really moved video surveillance to the cloud yet, pretty much across the board. But it's starting to happen, and we're hopeful that we'll play in that zone.
I assume law enforcement is a big component of your business because you have this data, so there's interface between you and various law. Is that
There's no interface between us and law enforcement. Like the video in our platform is owned by the owner of the cameras, and if they want to give it to the law enforcement, the owner makes that decision, not us.
so? If law enforcement contacts you, is that a situation where you might have to provide them?
If we get subpoenaed, but we have to abide by the laws of the country that we operate in. We're not going to break the law. However, we are not going to voluntarily provide video that is owned by one of our customers without their express written permission.
You were talking about safety and anomalies, and I was thinking a lot of people use surveillance for theft, which naturally meant law enforcement. So
Yeah. I mean, the primary driver of the business is still security and safety. Okay, the operational stuff of I want to optimize my lines at the grocery store, or I want my manufacturing line to run better, or I want to do this or that, kind of optimize my business, is still a relatively modest portion of the business. All right, thank you very much, everybody. If you need to get me, get me.
Thank you, Dean. All right. We have one more speaker for the evening. Oh, yeah. Yeah. So I'll give him an introduction while he's getting set up. Dan Gural is a seasoned machine learning evangelist. So he is a teacher. He's someone who is very passionate about open data, which obviously makes him a man after my own heart. If you found this on LinkedIn or anything like that, you probably know that I'm a big advocate for open data. So we definitely have some agreement there. He takes a leading role in efforts to bridge the gap between practitioners and developers of artificial intelligence technologies and the necessary tools, enabling them to achieve exceptional outcomes. So everybody give a hand to Dan Gural.
Everyone, thank you for coming out. I appreciate everyone, and thank you to Eagle Eye Networks and Dean for hosting us, allowing us to co-sponsor this event together. I'm really excited to dodge falling things and bring this talk to you guys today. So my name's Dan. I'm a machine learning engineer and developer relations at Voxel 51. If you haven't heard about Voxel 51 before, we are the lead maintainers of the open source library 51. We are a data set management house, refinery, curation center for any of your visual AI, computer vision projects. We help you find your data, curate your data, find your mistakes, and just make sure that that data set's going to be as high quality as possible. And we'll be talking about that a little bit on, but really what I'm here to bring you today is talking about drone surveillance, right? Surveillance is a big theme of the day. I have a soft spot in my heart for drones, as it's a very interesting problem given the environments that you have to deploy to. I've been working with cameras and AI for about 7 years now. I've been working with drones for a little bit shorter than that, I guess. So I previously worked for a quantization firm, if anyone knows what quantization is, where basically you can take AI models and shrink them down to put them on smaller devices. Naturally, that meant I was working with drone companies almost all the time. I worked with drone companies for over a year and a half, whether they are the military, private, contractors, you name it. I've probably seen the drone of that flavor beforehand. And so I'm bringing you all the lessons that I've learned from it, what it means to work with AI and drones today in 2024, and what problems you're going to be talking about. So what we're going to be talking about, we're going to start with what is a drone, as we got to be on the same page before we get started here. We're going to go into how drones and visual AIs looks like today, why these projects often fail, and when I say often fail, I mean often fail. How Gen AI is coming to bridge a lot of these gaps, and then looking to the future about how we can best prepare for the projects today and tomorrow, right? So jumping into it, what is a drone? Well, Merriam-Webster defines a drone as a long, low-sounding humming noise that goes on for a long time. Now, I'm just joking. A drone can be any autonomous vehicle, right? Whether it's a flying vehicle, like one of these. Usually it has some kind of onboard compute ready for it. The typical ones we see are either NVIDIA Jetsons or the Snapdragons. And when it's autonomous, there's a clear task it's going to follow. However, in 2024, we find that that's not really the case anymore. A drone typically just means a somewhat autonomous vehicle, whether that's a UUV, which is a underwater drone in this case, or it's one of these land-based drones. Of course, we probably normally think about drones, we think about the small flying helicopter ones, right? But they really come in all shapes and colors. We typically have onboard compute that still kind of stays the same, but not always a Jetson or a Snapdragon. Sometimes you have really, really big, people are packing in NVIDIA biggest graphic cards into these drones. Sometimes they're even smaller. And usually the task is not that clear, right? Because if I tell you to go detect something or find something for me, 9 out of 10 times I want you to do something after that, right? I don't want you to just find something for me. I could probably find it myself, right? I want you to find and do something, right? And so sometimes the task can change based on the environments or what is happening at the time. So how does this look like with AI and visual AI? Visual AI, for everyone that's here, is kind of this new blend of computer vision, how we're thinking about it today. The same way that we used to use the word machine vision, right, to do all this classical computer vision in the past, whether it's your fast Fourier transforms to understand images better and such like that. Computer vision is kind of this now, quote unquote, antiquated way of thinking about computer vision, with the advent of things like transformers and LLMs and this bleed into other visual systems like LiDAR and radar, as well as other new systems. We're now kind of putting a new blanket statement over it for now visual AI. So I'll kind of be using that throughout. For all intents and purposes for this talk, you can make it synonymous with computer vision. So drones and AI are kind of a perfect match, right? There's so many tasks out there that require these visions on these drones, whether it's things like piloting it, steering it, and kind of performing whatever that autonomous task might be. A lot of times these drones are going to be loaded up with the latest and greatest in computer vision, right? Many times these things aren't staying out in production for many years. They're often being brought back into the lab. They're getting pulled back in, changing the models out, and putting the best one up, right? And this process altogether maybe takes only a couple minutes to update to the newest model. So this transfer process isn't too long. And we still see that the number one use case by far is surveillance, right? Everyone wants to take a drone to fly somewhere that I can't fly myself, right? Or at least it's a lot cheaper when I use a drone. And maybe this isn't fly, maybe this is driving, maybe it's going underwater, right? But all the number one things that these things have in common is it's much cheaper and easier for me to have this autonomous task, to have the eyes in the sky, so to say, than it is to send a human out and collect the photos themselves. And a lot of times it's really easy to automate these tasks, right? I'm just going to tell you, fly 500 meters that way and then come back to me, right? And that's good enough for a lot of these use cases. Of course, sometimes they get a little bit more tricky as terrains change, size of the drones change, weather conditions can come up in handy, but they're all kind of going around the same point. If I have an area that you need to patrol, and I need you to come back to me in case something happens in that area, you can define that however you like. Today, what we see, and we're going to talk a little bit about the models and what is actually being used today, if to stay up to date, I would say that 90% of all drone projects, whether you're in the military, in the government, commercial, or whatever it might be, are all using some type of flavor of a YOLO model. Typically today, the best, most popular YOLO models are coming from Ultralytics. They're the creators of models such as the YOLO V5, YOLO V10, and YOLO V7. You gotta be careful because the numbers get switched up. YOLO V4 and 8, and some come from other places. But they are the lead maintainers. And why does everyone want to pick these YOLO models, right? YOLO stands for You Only Look Once. It's because it's a very quick model. It works really well. It's very powerful. It's very accurate. And it's really easy to use. I tell a picture, I send it to you, and you're going to draw little bounding boxes on all the things I'm interested in, and I'll know all where they are. It works if you have hundreds of bounding boxes. It works if you only have a bounding box every now and again. But it's really easy to work with. And another big component to this is it comes in many flavors, right? Every YOLO model comes with a small, medium, and large, as well as sometimes a nano for extra small, or an extra large model to be even bigger. This allows you to deploy a fleet of drones, where you sometimes have big drones and medium drones and small drones, and they can all be under the same family of models. That way you're not changing any of your code underneath. You don't have to change any of your API calls if you're using API calls. All you need to do is just swap the model out and say, well, this task needs to be more accurate. I'm going to put the large model in. It might run a little slower. I have to slow the drone down. But at the end of the day, all I have to do is swap these models in and out, and they will work all the same. This is typically paired up with some type of sorting algorithm. And sorting in this case actually means tracking, with algorithms like deep sort and strong sort being two of the most popular ones. And this is an extension of that object detection model that we were just talking about, where not only do I want you to draw bounding boxes on my images that tell me where the cars are, where the people are, and things like that, but I want you to tell me if you've seen it before, right? This way we can actually track in a video over time how things are moving around. For instance, whenever we work with videos, if anyone tells you that they're working with videos and AI today, what they really mean is they're working with the frames of the video, right? To track the context of video over multiple different frames, especially long extended periods of video, we're talking past 5 minutes of video, is an extremely difficult problem that even the best minds in AI have yet to really find out a practice to do this. So we have these intermediate gaps here, such as these tracking algorithms, where we can employ classical statistics to figure out, hey, this bounding box looks a lot like the bounding box I saw in the last frame. That's probably car number 2. And you can do this for every object in your box, or in your picture, so whether it's cars, if you want to track people, if you're counting things, this is often what people use to count things like fish, or the number of people that left and came in out of the CIA office today, for instance. You can track their cars and understand exactly how they're coming in and out. The downside of this is, yeah, it's not really like a long context video. For instance, if I'm on the camera now and then 30, 40 frames go by and then I come back in, are you gonna recognize me the second time? If I put a jacket on, are you gonna recognize me again? The weather conditions permitting, a lot of these fall off pretty quickly. But it is still commonly deployed today, especially in a lot of these drone environments. Deep sort and strong sort are the most well-known name ones, but tracking algorithms come out all the time, new ones. They're even using now diffusion models and transformer models to do this tracking for us and dropping some of the classical statistics. Because at the end of the day, if we're doing the math, it's probably a bad model. If the model's doing the math, it's probably a good model, right? And then the last real use case that we're seeing here is a little bit next to it. It's not exactly what we see in surveillance. The first thing that comes to your mind is surveying difficult terrain or just surveying terrain in general. What this means is I can send a drone somewhere I can't go, personally, whether this is things like subway tunnels, nuclear reactors, large high-rise buildings, where I can't access these places, or I need to do a large area like a field, a battlefield potentially, a potential mission space, when we're thinking about the military use cases here, where I need this drone to fly through or drive through, however this might be, and just scan the area for me. What do I need to be aware of? Are there cars in the area? How does the terrain look like? Where's the uphill? Where's the downhill? Are there any cracks in my nuclear reactor? Is my building swaying anything, right? All these kind of questions where now we can just fly these drones up with a GoPro, essentially, fly it around in circles around your building, and I'll have an exact 3D render of your high-rise that I can give to you for you to understand for whatever reason you want to use for it after that. So you can basically sum up surveillance and drones in these two main use cases. One being either I'm tracking things in the scene, or I'm more interested in the overall layout of the scene. Can you paint that picture for me that I can't paint myself? However, a lot of these projects tend to fail. I would say 9 out of 10 is probably being generous. It's probably more than that. They're not able to meet production, right? You could hear these horror stories when you work in the drone business. We sent the underwater sub out to find out where the leak was in the pipe, and it never came back. And so that's $500,000 down the drain, Or, I flew this drone, and all of a sudden it tells me that, the minivan's a car, the car's a minivan, the truck's a bus, and the bus is a truck. And I don't know why, and I can't figure out how to get it to consistently give me the answers that I want. And that's kind of the problem here, is this idea of a perfect data set in drones. Because unlike a lot of other problems in computer vision, we're faced with problems that have a lot to do with the environment that we're working in, right? Whether it's the height above the target we're thinking of, the angles to the targets, where my target is going to be deployed. And very often, what is the case is I actually can't go and get the data myself, right? Wherever I'm going to be deploying this drone, well, if I could have the drone there all the time to get this training data, then I probably, just would be doing that in the first place, right? But that's not the truth with a lot of these times. It's not legal to fly my drone around high rises of New York, unfortunately. I'm not able to go to war-torn Ukraine to get these videos of drones, unfortunately. So when I try to make applications to solve these problems in these locations, I'm unable to get adequate training data to solve these problems. Sometimes people also think that they have this idea of this perfect data set. He said, my son, he's really into drones. And he went out and he flew his drone for hours and hours this summer, and he got me great, perfect training data. And what ends up happening is that sometimes perfect is too perfect, right? I worked in a project with the Navy, and they were testing their underwater sub in San Diego. If you've ever been to San Diego, beautiful, beautiful city. Very clear waters in the scale of clear waters in the world, very clear waters. So just because you could see the things underwater in San Diego, if you go and drop the sub in the Mediterranean, it's not going to do it, right? So almost not perfect is almost better than perfect when it comes to drone data. And this is hard line to follow here. One main case here is the distance to the target, right? And this comes up over and over and over and again, that the model is not able to deal with the change of the height to the drone or the height to the target, right? So if you get most of your data and you're 50 feet above the target, if I go and I drop this drone in and I only fly it 20 feet above the target, well, it's probably just going to give me garbage results. Why? Because it's never seen 20 feet before. How would it know, right? So thankfully, there's been some research into this field within the last month about now we can actually predict the height over targets, right? You give me a picture, I'll tell you how high up I am, only using transformers. That's what we see in this bottom image here. But it's still a very difficult problem for us to solve, and now we're thinking about how we're going to drive the drones, the whole other mess of taking AI models and drive and pilot the drone. So this is one of the main problems that we see in making AI for drones. The other one is this repeated patterns problem, where whatever my training data is, somewhere in there, there's a repeated pattern that I'm not trying to capture, right? So in this case, one of the best available drone data sets is this roundabout data set, where someone parked their drone for several minutes above roundabouts in a city and basically watched all the cars go around the circle. What they unfortunately had a side effect for was that if I am not at a roundabout, then I cannot detect cars. I don't know how to see a car if it's not at the roundabout. I start detecting random things in this car if there's no roundabout, because I only know that there's no cars in the middle, and I know there's probably cars around this circle, right? And so you start teaching your model things that you don't want to be teaching it, right? And this is kind of like that perfect data set problem as well. Another very classic example of this is I tell someone, hey, I have this new car that I'm really interested in doing surveillance on. It's Mazda. So I need you to go out and take pictures of this Mazda. And so they go and they get hours of film, and all these hours of films, it's just the drone directly above the Mazda. And it just follows the Mazda around wherever it goes. And it turns out if that Mazda's not exactly below my drone, if it's a little bit on the outside, if it's on the side of my image, I have no idea what a Mazda is. I've never seen one in my life, right? All I know is that if there's a car directly below me, it's a Mazda, right? So it's like, this is when we had to think about for both on the data collection and data curation process, how can we describe the problem to our models in a way that's going to make sense for our model? And one of the best ways that we can do this today is with Gen AI, right? This is coming out within the last 6 months to a year, how we can really start to bridge these gaps. And one of the ways that we do this is when I fly my drones in places where I'm allowed to fly my drones, let's say like San Francisco, one of the common things is I want to be able to detect cars, caravans, something like that, moving on the streets. But I really want to be deploying these in places where I need to be deploying drones, right? This tends to be war-torn countries, conflicts, military engagements, things like that. Unfortunately, for these companies, not for the world, there's not a lot of data on that, right? There's not a lot of drones flying through these places. There's not a lot of publicly available data. So if you want to make one of these applications and bring it to market, you're going to have to do some in between. And so with Gen AI, with now how we can prompt these diffusion models, given either text, images, we can do depth maps, we can do normals now in our images, which are all these different ways to structure our image where I can now give it an image, let's say like San Francisco, or I can give it an image like this next one, where I can say, hey, I know there's a car in this image, but I really want you to replace it with a tank. And so I can actually just swap the pictures. I just tell my diffusion model, replace the car with a tank, And all of a sudden, now I have my tank data set that I wasn't previously able to do before. These images could be crisp. If they're not up to your snuff, you can change the prompt. Say, make the tank look a little bit scarier. Make the tank look a little darker, a little meaner. I can say these words that mean nothing to tanks, but I will be able to get the images out that I'm expecting. We can see within the last 6 months, 3 months even, how much further we've been moving in this field of replacing things in images, changing the way images look to get really high quality data sets. So the next part is in painting. This kind of goes along with what we were talking with the tanks. But things like, how can I actually upgrade my pictures? Because when I flew my drone, it was cloudy that day. But maybe I'm not going to be flying my drone on other cloudy days. Can I change my cloudy days to sunny days? Can I change my cloudy days to rainy days, snowy days, you name it, right? How can I make my data more diverse without having to go out and collect more data? And so with these new diffusion techniques, with these new Gen AI models, you can now describe days, your perfect weather days, you can see the temperature, whatever you want to these models, and they will actually populate these images for you, so that way you can actually diversify your data sets doing this. Another example here is, I'm going to fix my HDMI real quick, see if it gets better, so it's not so blurry for everyone.
We've been trying. I don't think it's going to work.
Okay. Well, you can do what you can do. So another way we can do this, right, is if I want to replace that image, you can see just over the last couple days or months how much better it's been getting. Where if I take out this middle block of my image and I ask some of the latest models, we go left to right here, how much better they're getting, right? Before we have those blurry things. We think about the people with like 7 fingers and the old Gen AI pictures where you said, oh, if you want to know if it's generated, look for their fingers, right? That's really not a thing anymore, right? And that was only a year ago, potentially. We're seeing these models getting much better, much faster, because at the end of the day, we need to make sure that the structure of the image is correct, or else we're just going to have our model detect synthetic images versus real images and not actually tanks versus cars, right? So as we look to the future, how can we actually apply these problems? How can we prepare our projects to be ready for drone data? And how can we make sure that we're doing all the best practices to capture these problems? So what do I need today? Well, the most important part of your projects is going to be your data, right? If you haven't gotten that already, I'll start from the beginning, I'll restart, maybe I'll get it better. But the data is the most important part here. The models can be swapped out. There's going to be new models. There's a new model today. There'll be a new model tomorrow. And if you're not prepared to switch from the old model to the new model, then you will fall behind from a competitive standpoint. The next part of that is when you're trying to source these data sets, Frankenstein data sets are the most common in the drone space, right? You are not going to find one drone data set out there that's going to solve all your problems. It's just a pipe dream, right? Given the confidentiality of these drone data sets, given the limited amount of open source drone data sets, you just are going to have to go out there and make the best with what's available to you today. Whether that's piecing together multiple city data sets for car detection, if it's doing these Gen AI augmentation techniques to get to the data sets you want to do, you're going to have to work to get to the data set that's going to get you to the best performance. And then after you're selecting this data, it's all going to be down to the correct environment. Does the scene look like where I'm deploying to, right? It's the same type of city, it's the same type of weather. The camera lens is the same type of camera lens I'm thinking of. It's going to come down to things like the angle, right? Is my drone bird's eye view always 100% on top of my target? Or does my drone fly through on angles and I see different sides of cars, right? Because the top of a car looks a lot different than a side of a car, for instance. It's also going to come down to things to like height. Am I flying my drone at 300 feet or am I flying my drone at 30 feet? And labels, making sure that your labels are strong. Because at the end of the day, if you have all these other ones correct, but your data set labeling is just poor, the boxes are off, cars are trucks and trucks are cars, and what really is a van, you're not really going to train your models at the best performance. So we can see some examples here where we have this big bus that's unlabeled that we need to fix in our data set to make sure that we're labeling this bus. As you can see, all the other light blue ones are labeled, but not the dark blue bus. As well as just managing your data in an environment that you can actually access these annotations, find these mistakes, and fix them. On top of this is managing your models and your labels. So annotations for drones is more than just bounding boxes now. We're seeing things like segmentation maps, depth, right? I want to know how high my drone is. I want to know what the terrain is. We also have 3D scenes now for drones, right? To make sure that when I do this nuclear reactor surveying, that it actually looks like this nuclear reactor. It's not just all over the place. And you really have to compare your models by their test cases. If you run over your whole data set and you say, well, Model A is 95% accurate, but Model B is only 87% accurate, well, surely Model A is better. Well, you cannot rely on a single image or a single number to find out the accuracy of your drone data sets. It just doesn't work. I've gone into bickering fights with Lockheed Martin over this. I've gone to war with other Northrop Grumman, whoever it is, that you can't just look at one number to determine the accuracy. And the fact is that there's different test cases for different problems. And if the moment my drone drops 10 feet out of the air for whatever reason, I can't detect a single box, then my model is garbage overall, right? If it works perfectly in my perfect test case, that's all well and good, it impresses your boss, but the moment it gets deployed, it's not gonna work, right? So we need to find a way to find the different groups, the different clusters in our data set, find out what the main use cases, the main test cases in my data set were, right? Some are really low, some are really high, some have a lot of detections, some only have a little bit of detections. And how do I do in each one of these use cases? That way I can then get the best out of my model, right? That way my application's working and everything's drumming along all well and sweet. And so we're gonna take an example of looking at VizDrone, which is one of the biggest data sets available for drones data sets. It has 6,471 different samples, but the most important part here is it has 550 different types of annotations. So it's very, very robust, and it's very crowded, right? Which is a very difficult problem for these drones. It also features a variety of angles, locations, as well as many different label types. It's not just cars, it's not just people, it's combined data for all of them. So I'm gonna go a little bit behind the curtain here to pilot my laptop for a second here. I'll continue to wave along from here. But we can head over to this website. If anyone wants to check this out, we're going to be looking at the try.51 example. It's publicly available for everyone to use online. Just head over to try.51.ai to get a look at this. What we're looking at here is the open source tool 51. Everything that we're going to be seeing here is completely free to use, open source to use. All it takes to get started is a pip install 51. The data set is publicly available. We have examples online on how to access it. You just look up 51 VizDrone or anything like that, and you'll be able to access this, as well as this example online. So with this, I can make this a little bigger for everyone too. We can actually go in and find these test cases using 51, right? So if I click this button, I want to find my most detections. I will get a little code example here for what my, how to find the most detections in my data set. It's going to scramble through all my data sets here, all pixely-like over here. And once it finally lands on them, I'll find my data sets with the most. So when I click into this image, I can see just how many labels are in this one. I can go look through how all these ones look like, so we can see crowded city streets with labels like cars and people and pedestrians. We can even turn any of these on and off, right? So I can turn off my ground truths. I have a single model here. I have another model here to see exactly how my models are performing, where the differences are in design test cases. I can even go into my embeddings panel, where I can use a model like OpenAI's clip model, where I can actually search semantically through my data sets. I want to find things like intersections. I want to find things like roundabouts, fast food chains, whatever you're looking for. You can search through text. You can search through the context in your images. But the best part about this is it helps you design those test cases I was looking for. So when I go over here and I select my cluster over here on the right, I will find very similar samples that are all happening at night in like city plazas, for instance. So maybe I need to figure out how this test case is and how my models are performing. But when I select a different side of my cluster, I'm going to get a different set of data. So when I look at this one, now we're looking at long highway driving. How does my drone perform on highways compared to cities? Likewise, I can grab the opposite of highways up here at the top of my cluster to find different, more up-close pictures of water, right? So instead of looking at grass, now we have water in our background. And using these tools like 51, you're able to load your data sets in, find your annotations, annotate, figure out your data set, curate, find your mistakes automatically, most similar samples, all these great things. But when it comes to drone data sets, it really comes down to these clusters. Are you able to understand the distribution of your data set, find the different groups of things, and these will help you find things like the angle of your heights, the environments of your heights, as these clusters will be more closely related to each other, and it helps you design more accurate use cases, where like in this use case, I have multiple models, a model A and a model B that I'm testing against, and I can find exactly where those differences are, what their accuracies are within these clusters, not just over the whole data set, and not just as across all labels, but even individual labels. So I know exactly how well it's predicting on pedestrians, in crowded streets, at night, or I know exactly how many cars are detected on a highway with the water in the background. All this is free to use, publicly available in 51. If you want to get started, pip install 51 to get started, or we have a guided demo that shows you all about how to filter, evaluate your drone data online at try.51.ai. You can check over there. We also have a couple other demos that we have up there. But I'll stop there, answer any questions if anyone has about drone data, 51, or anything else in visual AI. Thank you. So, any questions?
So this data is all free, right?
So yeah, I work open source data now. All the stuff I work with will be all free to use, open source, all publicly available to use.
So I am able to run any models on the data locally.
Yep,
And,
yep. So all the models that we've trained here are YOLO v8 in this case. So you can easily plug it in. It takes, let me count them, 7 lines of code to train a model with 51 and YOLO to get from loading the data in to looking at the model predictions onto your data. It's like 7 or 8 lines of code. So.
You have already, how many models you said? 8 of them? 8?
No, the model's name is YOLO v8, right?
So what transformer is being used for that model?
The transfer learning was from the original MS Coco ground weights.
All right, yeah, that's all I can. Thanks.
Yes. Daniel Garou's my GitHub account. I also have a Hugging Face account where I post my data sets to. So I like this data set. I have other ones for self-driving cars, tracking algorithms, and more available on my Hugging Face account as well. We have an organization on Hugging Face for Voxel 51 as well.
Quick question. I'm curious about the kind of meeting of the minds you had with Lockheed Martin. How did you ultimately kind of convey your point, and did they accept it, or did you just kind of treat it as a lost cause?
Great question. So they were like really, really, really fixated on their MAP score, right? Which is the accuracy score for object detection models. We were going back and forth for about 4 to 5 months until basically what happened was they gave me a data set. They told me the hyperparameters. They told me the model they trained, and they said, all right, well, train it to my MAP score, but I'm not going to tell you what it is. So, at least in the beginning, they didn't tell me. So I train it. I get back to them. I say, hey, it's my first go at it, and I got 40. And they say, well, that's crazy because we got 90. So, okay. Clearly, we're missing something here, right? Because we don't have this magic gap, right? There's kind of that rule of thumb in computer vision and AI in general of like, if my model's like 99% accurate, it's probably something fishy going on here, right? So we went back and forth on 40 versus 90 for about 2 or 3 months until they realized they were looking at the wrong number, and theirs was also 40. So that was one part of it. So just that alone was a big one. The next part of it was they were just like really fixated on the highest number possible because they have to go and report to people that don't know AI and things like that. And it wasn't until I used 51, before I worked for 51, to show them the actual side-by-side differences of like, look, this is your model, it's missing. And like, look, here's my model, and it's hitting, right? And like, I know that your model might be like 0.1% more accurate because it's doing really well on like the easiest images. But on the really hard images, you're missing like all of them. But you only have 10 hard images, for instance. But when you go to deploy, this is what it's going to look like. It's not going to, it's not going to look like San Diego. It's going to look like, what this picture looks like, for instance. So that's eventually how we got through that one. They were upset for a while, but we got through it. Any other questions? Well, thank you everyone for coming. I'll be around, help networking. Happy to chat more. Thank you, Daryl, again. And have a good night the rest of the night.
Good deal. Appreciate you, Dan. All right, guys, that's going to do it for the evening. One last request. If you guys wouldn't mind, before you head out, we want to take kind of a big family photo for our first event. So we'd love to have you guys, if you want to participate, take part in that. Also, we've got plenty of food, plenty of drinks, so feel free to grab some as you head out. And also feel free to just hang out and chill out for the rest of the time that we have the room and continue to network and engage. All right, appreciate you guys.
Canada just removed their women's soccer coach for using drones to spy on their opponents. There you go. Full circle. Crazy. What do you want everybody else to do? Time that one better.
That's old news. That's like 7 years ago.
Oh, my bad. 22 minutes ago, ESPN told me, okay?
We have a mission statement here about cheating.
Okay, everybody, say cheese. Cheese. Thank you all so much. Please take as many drinks or pizzas or snacks as you want as you're leaving. If you want to get some swag, go ahead.
I was doing a partnership program in China, and we posted like a big picture, and they were like, everyone's standing there, it's like really quiet, it's like late at night, no one wants to talk anymore. And this one person just goes, cheese. And didn't understand why Americans say cheese, just knew that we said cheese. So just the shortest, quickest cheese.
Question about the stuff. So in this case, I guess your model, so you're using generative models to augment the data.
Right.
And then so you have image data, and then you're training, when you're training the drone, that is some kind of reinforcement learning model.
So it depends on like what you're training towards. So like these things tend to be easier to build the more segmented they are, right? Because it makes it much more easy to swap parts in and out, right? So tend to be like this object detection model. It's what's 90% of the drones. You're training that model, and then you're going to drive potentially reinforcement routines based off the results of that.
So the model is going to, okay, in this case it's more exploration.
Yeah.
So it's
So
not
like if
how
you like see an object, you want to steer it, right? So basically this object in my ideal world is always right. All like the models I've been talking are trained to just find the box. Another reinforcement routine, model, agent, whatever you want to use, that's its job is to then take the results of that picture and then tell both boxes select whether you can drive right? Right? If one model that does everything, well, it's not going to work as much as the model. Yeah, like I know the ground is 50 feet below me, so I should probably stay there. If it's low, I get higher. So it depends on like exact good question. Yeah, right? A radar or LiDAR sensor. Like depending on like the quality of the sensor, LiDAR sensors can be anywhere from cheapest one that's just where the most expensive ones are like thousands of dollars, right? So it really depends on what kind of control you're having. So like a lot of these about, they use LiDAR sensors to scan the entire area. So the question is very open. The main point here is that don't cross reinforcement with vision. The vision model that's detected the scenes try my best to do it. It's like, okay, it's like I have to be kind of good at it. Yeah. I haven't done too much on Twitter recently because I use mostly on LinkedIn, but I'm doing more on my Twitter.
Get your pizza. I love it. I love it. Adam, thanks for the talk. Just a couple quick things. First of all, you speak assuming that's a skill you've honed over the years. If you speak that well naturally, you're in the wrong business. It's giving a presentation is not easy. You mentioned Drummond, my grandfather came from Bellevue. Wow. I have not only his one application, but I have all the annual reports. So anyway, there's not. I worked with a bunch of nerds. There's not a lot of Drummond's not around, but I mean, he started as a line worker, he had no education. I mean, anyway, a couple of quick questions for me. I am in finance, venture capital strategy is my subject, and I'm older, so when he talked about risk and 8088 processors, I understood. I knew the risk one. I still have the Commodore 64. I still have it. All right, I digress. I understand the technology to the business side. Translate. The biggest problems folks have is that all the data on the internet is being used to these generative models. And what I read on the periphery, not being as smart as you in these areas, is that when you use models, you use data created by AI to train AI, you get mad cow disease. It creates so you're talking about these Franken models where you take cars and the AI replace. All right. Is there, I want your professional opinion, generally speaking at a high level, is Moore's Law, okay? Everybody says AI is going to follow you. Is the AI going to actually go like this because you're going to have limitations in the ability to train the data and not get mad? Does this make sense to you?
Yeah, there's like two ways I would do it. Right? One is in military we have this problem called, I don't know what it's called. I call it the pinch problem, right? Where what if I found out that my enemy has a great model that protects my tanks and blows them up every time. I drive them to war. I found out that if I paint all my tanks pink, then they can't find them anymore. It's never turned out pink tanks. Right? So how are you going to iterate on this problem to then train your model to detect not necessarily green tanks or black tanks, but any tank
Or
or
one
pink
model
tank.
will feed data to another model to see what it screws it up, and then that's how it interprets.
Yeah, so there's ways to like figure out like why it's going the wrong way, right? So how do we running actual use case I think is very like mines, the
You were military service.
I right. So like triangles versus squares, hexagons, whatever it might be, right? But it's the next day, basically, nature starts being
One more, thank you very much, by the way. You have a balance on both sides. The AI is able to create videos and images that are indistinguishable from humans, from reality.
Sure.
On the other side, you have AI that's trying to detect those fakes, right? To my mind, movies from the 70s and 80s, the practical effects and miniatures are still better than the CGI. To me.
Yeah.
Right. What I want to know is this. Where are we on that balance of creating the fakes? Is that the stronger? And is that going to be a problem where what's going to win? The ability to generate them or the ability? Does that make sense?
Yeah, no, it's the greatest. It's the number one. Like, yeah.
So what
Gen
do you
AI.
think? But what do you think? Because if you ask me about the economy or finance,
Sure.
I can talk about
So
it.
today, unified thing. It's not an issue, right? The reason why is we, with our eyes, can't tell the difference. But if you were to really look at the pixels, right, you would find like unbelievable amount of pixels in the same image, right? Basically, like, it looks like a picture. It think that stuff will still be, yeah, I think people will still want their organic data and their training.
Thank you all. It was a really nice event. I'll come on the next one. Keep doing this. Great. Great. Thank you. Thank you.
Reimagined way that is indistinguishable from a real painting versus a fake painting. Yeah, I think it's just a matter of time. Especially if you scale the problem, like the less amount of pixels you give me, the easier the problem is. Like for instance, if you gave me 32 by 32 pictures, of course I could, right? So at what point do I not, right? Maybe today it's around 200 by 200 before it gets a little dodgy. Like 400 by 400, probably not. That number's only going to go up. So eventually we're going to hit like 4K. Know whether it's 4K or not is really not from check out like ultralytics. That's the model that I'm easiest to do this for. And then 51.
will you give your love? There's nothing more that we can do.